Have you ever wondered what the most dangerous place in the entire universe is? Your first thought might be a black hole, right? Those cosmic vacuum cleaners that swallow everything, even light itself. Or maybe a supernova, an exploding star releasing more energy in a few seconds than our sun will in its entire lifetime. While those are definitely terrifying, NASA has its eyes on something else. A place so bizarre and hostile it makes black holes look almost tame. It's a place you've probably never even heard of. So, what is this cosmic death trap? It's not a single object, but a type of star called a Now, you might be familiar with neutron stars. They're the superdense cores left behind after a massive star goes supernova. Imagine crushing a star bigger than our sun into a ball, just a few miles across. A single teaspoon of neutron star material would weigh billions of tons. But magnetars are a whole other level of extreme. They are a special, rare kind of neutron star with a magnetic field that is, frankly, ridiculously powerful. How powerful? Let's put it into perspective. The Earth has a magnetic field that guides our compasses. A typical refrigerator magnet is about 100 times stronger than Earth's field. The strongest man-made magnets in our labs are a few 100,000 times stronger. A regular neutron star's magnetic field is 1,000,000,000,000 times stronger than Earth's. But a magnetar. A magnetar's magnetic field is 1,000 times stronger than even that. We're talking about a quadrillion times the strength of Earth's magnetic field. That's a 1 with 15 zeros after it. This magnetic field is so intense it defies the laws of physics as we know them. It's strong enough to warp atoms into long, thin needles. The vacuum of space itself is believed to become polarized, something that shouldn't happen. If you were to get within about 600 miles of a magnetar, its magnetic field would literally rip you apart, atom by atom. Your body's own magnetic fields, the ones that help your nervous system function, would be overwhelmed, and your molecular structure would disintegrate. There's no spaceship, no material we can even conceive of that could protect you. But the danger doesn't stop there. Magnetars are incredibly unstable. Their immense magnetic fields are constantly twisting and shifting, causing the star's crust to crack. These are called a small starquake on a magnetar can release more energy than thousands of solar flares from our sun. In 2004, a magnetar named SGR 1806-20 had a major in just 1/5 of a second. It released more energy than our sun has emitted in the last 100,000 years. This burst of gamma rays and X-rays was so powerful that even though the magnetar was 50,000 light-years away, on the other side of our galaxy, it still had a measurable effect on Earth. It ionized our upper atmosphere, disrupting some radio communications. It was the brightest event ever detected from beyond our solar system. Think about that for a second. An event that happened 50,000 years ago, on the far side of the Milky Way, was still powerful enough to hit our planet with a wave of radiation. Now, imagine if a magnetar was closer. If one of these starquakes happened within, say, 10 light-years of Earth, the consequences would be catastrophic. The initial blast of gamma rays would strip away our ozone layer in seconds, leaving us completely exposed to the sun's deadly ultraviolet radiation. This would trigger a mass extinction event, wiping out most life on the surface and in the oceans. The sky would be lit up by the radiation, and our electronics and power grids would be fried instantly by the intense magnetic pulse. It would be an extinction-level event on a scale we can barely comprehend. Luckily for us, magnetars are extremely rare. Scientists estimate there are only about 1 billion neutron stars in the Milky Way, and of those, only a tiny fraction, maybe 1 in 10, become So far, we've only confirmed the existence of about 30 of them. And even better, none of the ones we've found are anywhere near us. The closest known magnetar is thousands of light-years away, far too distant to pose any threat. So why does NASA and the scientific community spend so much time studying them? Because they are natural laboratories for extreme physics. The conditions inside and around a magnetar are so intense, they can't be replicated on Earth. By studying them, we can test the limits of our understanding of magnetism, gravity, and quantum mechanics. They help us answer fundamental questions about how the universe works. For example, some mysterious phenomena, like fast radio bursts or FRBs, are now thought to be caused by These are millisecond-long bursts of radio waves from deep space, and for years, we had no idea what caused them. Now, we have strong evidence, linking at least some of them to these magnetic monsters. The life of a magnetar is also fascinating. They don't live forever. Their intense magnetic fields actually act as a brake, causing them to spin down relatively quickly. After about 10,000 years, their magnetic field weakens, and they eventually settle down to become a more ordinary neutron star. It's a short, violent, but incredibly spectacular existence. So, while a black hole's event horizon is the ultimate point of no return, a magnetar is a place of active, violent, and inescapable destruction long before you even get close. It's a celestial object that can tear you apart, atom by atom, from hundreds of miles away, and sterilize a planet from light years away. They are a stark reminder that the universe is filled with forces beyond our wildest imagination. These cosmic titans, with their quadrillion Gauss, magnetic fields, and planet-cracking truly earn the title of the most dangerous places in the universe. It's a good thing they keep their distance. Thank you so much for joining me on this journey to the most extreme corners of our cosmos. If you enjoyed this and want to learn more about the universe's mind-bending wonders, be sure to hit that like button and subscribe for more videos. Let me know in the comments what cosmic mystery you'd like me to explore next. Until then, keep looking up.